Chapter 20, Shaping Earth's Surface. So in the last chapter we talked about how plate tectonics plays a role in building the larger structures that we see on Earth, things like giant mountains and things like that. But from that, there are still much smaller structures and fine details that are on the surface of the Earth that are formed in other ways. And so this chapter is going to focus on how those giant structures that are formed from large-scale movement of plates are then over time, over millions of years, turned into what we see now. So obviously, even though there are rock structures all over the surface of the Earth, they can change over time. These changes result from things like breaking up the rock, or chemicals breaking down the rock, or something else breaking down the rock. But any type of process that breaks rocks apart, we call weathering. Weathering contributes to the rock cycle. It breaks rocks up and allows them to move to other places, which can then change their conditions and change what happens to the rocks. It also allows for sedimentary rocks to form. It leads to the formation of soils, because this is how things are broken up from rocks and other biological and chemical elements. It allows for the movement of rock materials over Earth's surface. If rock's broken apart, it's much smaller, it's easier to move, and so it can move across the surface. And the process of moving weathered materials is called erosion. Erosion is often confused with weathering in general terms, but erosion refers to the physical movement of weathered materials, the actual picking up and moving of these smaller broken down pieces of rocks, as opposed to the act of breaking them. So the first type of weathering is what's known as mechanical weathering, and this occurs when something physically breaks a rock. So these types of processes can occur when you have objects colliding against the rock, or trees growing into rocks, or large pieces of ice forming near the rocks, breaking them apart, or water in the ice freezing, breaking them apart. When you have obstructions like that, this is what's known as wedging, and it will break down rock. Another form of mechanical weathering is what's known as exfoliation. This occurs when you have rocks that have a change in a pressure situation. So, for example, if you have a rock that comes up from the inside of the Earth and is then exposed to the surface of the Earth, the pressure differences will cause the rock to sometimes expand and break apart, and this is what you see here up on the top right. Second type of weathering is what's known as chemical weathering, and this occurs due to chemical reactions with elements inside of rocks. This can occur in a number of ways. One is what's known as oxidation, so you have reactions with oxygen inside of these rocks. This will produce red iron oxides and red areas around usually water deposits. The second is carbonation, and this is reactions with carbon dioxide that's dissolved in water, also known as carbonic acid. This can easily dissolve limestone. It can also dissolve other rocks, and it's the primary form of acid rain. And this occurs naturally from the carbon dioxide and water vapor in the air. The third way is hydration, and when you have water passing by something, water can react with chemicals or dissolve chemicals in parts of rocks as well, and this will dissolve small pieces and carry it with the water. So all this weathering forms soils, and soils are just mixed up pieces of weathered earth materials and what's called humus, which is decay-resistant plant material. These weathered materials include sand, clay, metal oxides, and salts. In general, we have topsoil, referred to as loam, and you have subsoil, which is generally less fertile than the topsoil. So once the materials are weathered, erosion can occur. Erosion just refers to the mass movement of these particular weathered materials. It is directly caused by gravity, but gravity causes other things to happen. So one way that erosion can happen is by means of a landslide, or by weather materials just sliding down a hill. Over time, gravity will just drag those down. That doesn't require anything to happen except for gravity to pull over time. But there are other agents of erosion. There are other things that occur on the Earth that can move these weathered particles, that don't just react to gravity. For example, the most important agent of erosion on the Earth is running water. Water moves everywhere, and it can pick up a lot of weathered materials, and it can carry those materials over long distances. In general, when we refer to moving water on the Earth, regardless of its size, we refer to it as a stream. And streams can transport all different types of materials. They can transport dissolved materials, so things that are dissolved in the water and carried down through the water. So think salt, but other materials can dissolve in the same way. They can carry suspended materials, so just like rocks and dirt and stuff in the water that doesn't dissolve, it just carries along with it. And they can move rocks along the bottom of the stream bed, depending on how quickly the water's moving and what types of rocks they are. And so what that means is that streams, rivers, moving water on the surface of the Earth, they evolve over time. They change, primarily because they're changing what's around them, because the water is moving. It's never constant. If the water is moving, something about it is changing. So what you see is that over time, streams will cut into land And then the movement of those streams will cut away at the land, and over longer periods of time, the land will essentially flatten out nearby the stream, and it will somewhat meander around in that general area. This comes about from just erosion over time. You start off with these V-shaped valleys, and as the water continues to cut into those valleys, it'll eat away and move around, and the gradient, which refers to the slope of the ground, begins to flatten out. And then as it gets older and it can meander and move around more, you see more floods in that general area because the region is flatter, and the stream can kind of do what it wants in that general area. It has no real obstructions. You can think about how water runs down the side of a cup from your finger. It doesn't flow all in the same direction all at once. And that's because that area is smooth, there's no obstructions. It's more chaotic of a flow. It can kind of do whatever it wants. The same is true for streams as they get into that old age range. At the end of streams, you see plate regions where those weathered materials pile up, and you get deposits of sediment. These are called deltas. These occur in places where you have streams that run into gulfs or oceans or lakes. And once these things hit the oceans, they can no longer erode or carry stuff. The oceans just don't really move in the same way, and the water just kind of runs into it, and everything just kind of falls and stops and drops off there. It can't really move through the oceans. You can again think about the water running down a cup. If it then drops into a pool, it dissipates. It can't move anymore. The pool doesn't appear to be moving. If water is the most important agent of erosion because it can move the most stuff around, then the most powerful agent of erosion are glaciers, because glaciers can move the biggest rocks. Glaciers are just masses of ice that form on land, accumulated snow over time. They piles up, then freezes into giant blocks of ice. And eventually those giant blocks of ice start to flow with gravity due to their own weight. Gravity essentially pulls them down. These glaciers have to get up to a certain size, and once they reach that certain size, they can move on their own weight, and they'll cut into rocks and cut large pieces out of rocks. There are different types of glaciers. There are alpine glaciers that form at high elevations, and then there are continental glaciers that can form over large areas of continents, like Greenland and Antarctica. Alpine glaciers can form and cut valleys into mountains. So erosion by glaciers can occur in three different mechanisms. The first is bulldozing, which forms deposits called moraines. A second is abrasion, which produces rock flour, which is just sand and silt and all sorts of stuff mixed together, crushed up little powderized rock. And then the third way is plucking, which is when water freezes into the rock that's nearby and just grabs it and takes it along with the glacier. So these mechanisms allow glaciers to move the biggest rocks. Just carry those big rocks with them, but they can just break those rocks into big pieces and just carry them along with them, or get frozen into the rock and carry them along with them. Perhaps the least efficient agent of erosion is wind. However, wind can move the smallest particles. It can move the tiniest particles, longest distances, but it doesn't move that much stuff in general. And so this occurs by abrasion, when you have wind blowing hard against some rock or something like that. Think of it as natural sandblasting, pulling little pieces of the rock off and moving it. Or by deflation, when you have particles that get picked up in the air and they're carried away. So again, both of these processes, weathering and erosion, lead to the development of landscapes. It takes these broad features that are formed from the movements of crusts, and it forms particular features on them, cutting rivers or rivers cutting valleys, canyons and giant lakes formed from glaciers cutting into rock and then melting and receding. And so we can kind of generalize how landscapes change over time based on how their rock is structured, so how much has been done to it, how much of a fresh piece of crust is it, how much weathering and erosion has occurred, and what stages of erosion. So the rock structure is just referring to the types of rock that are there in that particular landscape. So whether it's igneous rock, which means there's probably a volcano or some magma vent nearby. If there's metamorphic rock, it is in general resistant to chemical weathering. Or if there's sedimentary rock, it is susceptible to chemical weathering. And so that could determine how the landscape formed. The attitude of the rocks, which just refers to how easily they break or fold, and whether they could break or fold, or whether something could cause them to break or fold faster or slower. The landscape would also depend on where it was located. So climate influences, elevation. This implies what types of erosion processes would occur. Would there be running water? Would there be glaciers? Warm, moist climates imply a lot of chemical weathering. Chemical reactions in general occur in warmer temperatures because the particles can move around more, have more collisions, and so more reactions occur. In drier climates, you have more mechanical weathering. Less movement of water means that you just have more rocks hitting each other and breaking apart, or something to that effect. In these landscapes, you have sharper, more angular outlines, bigger, pointier things. And so we can talk about the stages of development of a landscape, which is just talking about how we go from the youthful stage where weathering and erosion are at the beginning, and you have very steep mountains, steep valleys, and then over time these things are worn down to smoother slopes and less peaks, and then they become flat, and you can have rolling plains or floodplains near water. And then some type of rejuvenation can occur if you have land uplifted from some type of crustal process or something else, magma or something moving up from under it. And you can have those erosion processes begin again.